Hello viewers, welcome back to class. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos when being uploaded. Guys, don't forget to avoid every unnecessary distraction. And don't also forget that we do not entertain you skipping any part of this video because it will not do you any good. So for you to take full advantage of the content that we teach here, please do not skip any part of this video. It is for your own good. And also don't forget to replay the video over and over again until you understand an aspect that you have not understood. Maybe when you watch it for the very first time, you have the singular opportunity to watch it over and over and over again until you acquaint yourselves with the principles. Listen carefully, guys. We are here to continue from where we stopped. And in this tutorial, we are going to be looking at certain equations. How some certain equations or the basic equations that we are going to be using in solving problems under second order differential equation for a case 1. We are going to derive the equation that we'll be using to solve problems hereafter. How the equation comes about. The origin, we want to quickly look at the origin of these questions, of this equation. Now guys, let's get to work. On the board, we have solutions to second order differential equation. And like I explained earlier, there is no way you can provide solutions to differential equations, second order differential equation effectively without you knowing the case that the particular question you are given belongs. Very, very important, because you must know the source of your question to be able to provide necessary solutions. Just as it is very important that when you know boundary conditions, you will not overstep your boundaries, right? And when you understand principles, you gain mastery over that aspect of life. Now, that's exactly what happens here. So, in providing solutions to second order differential equation, there are two cases. So, we want to quickly look at case 1, when f of s is equal to 0. And we said that the f of s is always at the right hand side. So, we just replace f of x with 0 now. This is equation 1. And now what we are trying to deduce is that earlier on we said that the solution to this equation is given as a m1 of x plus b m2 of x. We want to deduce this result, this solution, from this given equation. Alright, so now let's have this done. The first thing you will do here, or that you must do here, is to convert this equation to a first order differential equation. Of course, this is second order differential equation. So we want to first of all convert this equation to first order differential equation. Now, why must we do that? Remember, when we were dealing with first order differential equation, I told you that before you can get the general solution, you need to integrate. And the reason why we solve differential equation is for us to eliminate the derivatives, whether the first order derivative or the second order derivative. That's what we remove. Is that correct? So now our interest is to ensure that the final result is a function of x and y. We will successfully remove this square y over this and this guy. And for us to be able to get this solution that we have here, we need to integrate and understand that you do not integrate for second order differential equation. No, you only integrate for first order differential equation. Please take note of this. When you know boundary conditions, you will not overstep your boundaries, right? So get this clear, that for first order differential equations, you integrate to get your final solution. But for second order differential equation, we do not integrate. We only use quadratic equation for case 1, and for case 2, we use quadratic equation and differentiation method. Are you there? So now, what must I do to be able to integrate here? I need to eliminate the second derivative. And how do I eliminate the second derivative? When I make the coefficient of the second derivative 0, automatically second derivative itself will be 0. What do I mean here? For me to make this function to be 0, I can decide to say, okay, let a be equal to 0. Just like in quadratic equation, we said that a cannot be equated to be 0 for a quadratic equation to be real. Therefore, if I want to convert a quadratic equation to a linear equation, what I do is to make a, which happens to be the coefficient of the highest degree, 0. Now, all I need to do now is to say let a be equal to 0. Now, at a equal to 0, we will obtain first order differential equation. Alright? This is what we are going to obtain. Now, therefore, we are going to have this as 0 multiplied by d square y over dx squared plus b dy over dx plus cy is equal to 0. Now, from here, everything here is already 0 because 0 multiplied by anything would have also given us 0. And then we ignore this. Automatically, we have b dy over dx plus cy is equal to 0. And now, guys, we equally understand that what we have here now is first order differential equation. Is that correct? Where you have dy over dx, first order derivative. So now, to solve first order differential equation, listen carefully, you know that the coefficient of dy over dx must be 1. So what must we do now to make the coefficient of dy over dx 1? We need to divide both sides by b. Are we there? So we quickly divide both sides by b. When we divide both sides by b, guys, this will have become dy over dx plus c over b is equal to 0 over b. So we just divided both sides now by b. Then automatically this will have given us dy over dx plus c by is equal to 0. Now at this point, we are quickly going to take the ratio of b to c to become what? A 1 value. So let's say, let c over b be equal to k. We just need to remove this fraction and make this fraction a simple what? Function or a simple term. So we are replacing this fraction by a term k. Then we have this equation as dy over dx plus ky is equal to 0. Now the next thing we are quickly going to do is to take this to the other side, because we are already solving first order differential equation, and to be able to solve first order differential equation, we know that the two variables that we have here now, of course you know that k is a constant, because k is a ratio of constants or coefficient, right? So k is a coefficient or a constant. Now we have x and y here, and understand that for you to be able to what? Integrate, or for you to be able to what? Provide solution to first order differential equation, you must separate the two variables. Alright? So we need to collect like them now so that we can separate x from y. Then we have this as dy over dx. Now as plus ky crosses, it becomes minus ky. Now what do we do? We have a function of y and a function of x. Yk is constant. So I need to separate kx from y. And to have this done, we said that all y functions occupy the left hand side and all x functions occupies the right hand side. If this is understood, all I need to do now is to separate the variables. Are you there? If you are doing this in exam, it is very, very advisable that you make your necessary statements. Alright? This is online videos. That's the reason why I'm trying to see how we can make this thing very short. So you can state it here by separating the variable, collecting like term, cross multiplying, dividing both sides by this. You must do those things. Okay? Now, here now, I have stated that we are separating the variables. So to separate the variables, all I need to do is to first cross multiply, or I will have dy is equal to minus ky dx. Right? So to take y from the right hand side to the left hand side, all I need to do is to divide both sides by y. Are we there? Divide both sides by y. And when I divide both sides by y, I'm going to have dy over y is equal to minus k dx, because the y, we cancel the y that we have here. Now that we have successfully separated x from y, what else do we do? All we just need to do is to integrate this function. And to integrate this function, we quickly introduce our integral. We have 1 over y dy is equal to what? Minus k integral of what? Dx. Don't forget that minus k is constant, so we take it outside the integral. When I integrate 1 over y, certainly we are going to have the y, which is equivalent to what? Minus k. When I introduce 1 dx, we have dx, we have x plus c. At this point, don't forget in mathematics that the x is something as what? Log base e of x. Don't forget this theory. So if this is possible, therefore, I can convert this to log e of y, which is equal to minus kx plus c multiply by log E of E. Why do I introduce this? Understand that one of the laws of long reading states that the log of the same base, the log of a number to the same base is 1. So I can introduce this. Why am I introducing this? So that I will be able to eliminate the lead function or the long function. I want to eliminate it. So to eliminate it, all I need to do is to introduce, since I already know that the base of this is E, I will introduce equal base. Then for this to be 1, I need to have the number and the base equal. Understand that everything here now is 1. So therefore, the next thing we do is to have log y base E. Are we there? Is equal to, we are going to apply one of the laws of what? Log reading again. That the coefficient of the log can become the what? The power of the log of the number. Are you there? Then we have this as log E exponent what? Minus kx plus c. Now therefore, this guy takes in of this guy. We then have y is equal to E exponent kx plus c. Now we know that in indices, for you to have the sum of two powers, it shows that they have common base with multiplication in between. Then I have y is equal to E exponent minus kx multiplied by E exponent c. This is what resulted to this. Now I'm going to take this as a constant. Let E exponent c be equal to what? A. Finally, we will have this as y is equal to a e raised to power minus kx. Now, let minus kn be equal to minus k. So the next thing we will do here is to remove this negative value and to replace that negative value k, because we want to bring in the m that we have in our equation, which stands for the auxiliary equation. Is that correct? We use m to represent the auxiliary equation, like I said earlier, that if you have this square, y over the s square is exactly the same thing as m square. So we want this equation to be in terms of m. And that's the reason why we are taking minus k as m. Now when we substitute these guys, we are going to have y is equal to a exponent mx. This is equation 2. Now guys, this equation 2 is the second order differential equation. But what we have here now is a result for one of the function, because we know that since we have second derivative here, we are going to have two answers. So what we have now is part of the answer, not the total or the general solution. Now, how do we get the general solution? All we need to do is to now differentiate this y that we have here. Now we have gotten y, which is exactly what we had here. So when we differentiate this y, we will have this. And when we differentiate again, we will have this. So now, the next thing we are quickly going to do here is to differentiate it. Now, when we differentiate this will have this. Anytime you differentiate exponential function, all you just need to do is to differentiate the power of the exponent. And this is ms. So when you differentiate ms with respect to x, we are going to have m next. So I have am e mx. This is equation 3. Then I will differentiate this again. This will y over the s squared. Don't forget that the second derivative is obtained from the first derivative. So to obtain the second derivative, you need to differentiate the first derivative. Now, if I differentiate this, understand again that it is the coefficient of s at the power of the exponent that will also come down. So m will come down to multiply this m. We are going to have this to be what? M squared. Then I have am squared e m of x. This is equation 4. All we just need to do now is to substitute equation 2, 3, and 4 into equation 1. Like I said, we have a destination where we are going, right? We want to obtain the auxiliary equation and also obtain the general equation. Like I explained earlier when we started, we said for case 1 of the second order differential equation, we have 3 equations. 1 is the equation you are given, 2 is the auxiliary equation, 3 is the general solution. Now guys, from the given equation now, we are out to deduce the auxiliary equation and as well deduce the general equation. This is our interest here, and that's why we are going through all of this journey. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. Like this video, share this video. Now guys, let's continue from where we stopped. So now, at this point now, we need to substitute equation 2, equation 3, and equation 4 into equation 1. And when we do that, we are going to have, when we put this one here, this would have given us small letter a, capital letter A, m squared, E, m of x. We are done with this. Therefore, the second case, we are going to have b multiplied am. Now, understand that dy over dx is what we are replacing here now. And dy over dx is what? Am e exponent m of x. So here we come. We have this. And this would have given us what? Am e m x plus c multiplied by y. This is c multiplied by y. And what's the value of y? Y is a e m x equal to 0. Now, when I look at these three terms that I have here, something is common. And what is common there? What is common here is a exponent mx. So I put down a exponent mx, open bracket, a m squared, plus if I remove a e raised to power mx, I'm going to have bm. And if I remove this from here, which is the common factor, I'm going to be left with c equal to 0. So all we need to do now is to divide both sides by this a exponential mx. When we divide both sides by a exponential mx, this will have cancelled. Therefore, we have this equation to be am squared plus bm plus c is equal to 0. This is equation 5. Alright? So now we have successfully deduced the auxiliary equation from the given equation. Any problem you are given, you don't need to go through this. All we need to do now is to apply this. But in this video now, our interest is to show how come about this equation. And that's what you have seen now. You have been able to deduce that by yourself. Are we there? Now, how do you now get the general solution from here? Now, look at this question very well. Or this equation. What does this equation look like? It looks exactly like what quadratic equation. Because we know that a, b, and c are constants. And now we have m to the degree 2, we have m to the degree 1, and we have m to the degree 0 here, which is constant. That means this is a quadratic equation. And we understand that from every quadratic equation, we have two results. Are you there? So like I said now, this is the auxiliary equation, equation 5. Equation 5 is what? The auxiliary equation. So from the auxiliary equation, that is when you get your final solution or the general solution. And now that we know that the auxiliary equation is quadratic, that means we are going to obtain two results from here. Therefore, the value of m is equal to m1, and the value of m also, and m is also equal to what? M2, because we are going to have two values for m. Now, this is where the condition now comes, that when the two m's are equal, when the two m's are different, and when the two m's, maybe one is complex and the other is what? A rational number. This is where the conditions come. But understand that for every quadratic equation, you have two roots. So therefore, if I solve for m here, I'm going to have m1 and m2. These are the two results. That shows that this general solution here, this would have become y is equal to, so this would have become y1 is equal to a raised to power m1 x. Then y2 will now make use of second m. This will have also given us b. We will now use another constant, arbitrary constant. Alright? E m2 of x. Now, for us to be able to get the general solution, I need to add this guy and this guy together, because what will give me the general solution to this equation would have been the sum of these two roots, the result for these two roots. Therefore, the general solution y is equal to y1 plus y2. Finally, y is equal to, what is y1? A e m1 of x plus b e m2 of x. This is equation 6. So guys, from what we have here now, we have successfully deduced the auxiliary equation, which happens to be equation 5, and the general solution, which happens to be equation 6. But like I said earlier, it is these two roots here that will now give us some topics under second order differential equation for case 1. So we are going to be looking at subtopics when M1 and M2 are different, when M1 and M2 are equal, and when we now have complex roots. This will be the cases where we will be providing solutions to second order differential equation. But understand that for you to be able to solve second order differential equation very, very effectively, you must understand equation 1, equation 5, and equation 6. All other equations that you have here, they are not necessary at all. We just use all of these steps here to derive the auxiliary equation and the general solution. So I think I deserve a hand of applause. I deserve a hand of applause, right? So don't forget to subscribe to this YouTube channel if you have not done so. And don't forget to turn on the post notification bell for more exciting videos. Guys, we love you. Share this video, like this video, and make your necessary comments. Please, guys, the link to the next video, you can find it at the description below. And don't forget also that you have more things to learn at the description below. So don't forget, anytime you watch our video, always check the description, because there are stuff there that will also benefit you in addition to what you have learned so far from the video. So guys, we love you. See you guys in the next class.